Okay, this is your well-rounded math teacher, Mr. Pickar, and we're doing Unit 7, Notes 2, Operations with Polynomials. So we'll kind of jump right into it. Degree of a polynomial is the degree is the power. Okay, let me try this again. Degree of a polynomial is the largest power of a term. Okay, so let's look at this. V to the fifth. Well, there's only one term, and the power is 5, so my degree is 5. Okay? So for this one, you got to look at each individual term. Here my power is 3, so the degree is 3. Here my power is 2, so my degree is 2. Here I don't have a variable, so for just the 9, that my degree would be 0. Now you take the largest power of all 3 terms, well, that would be 3. So the degree of this term is 3. This one's a little bit different because there's 2 variables in this first term. There's a 7 and a 4. So the degree of this term, 5x to the 7th, y to the 4th, would be 11. This is just minus 2x to the first, so the degree of this term is 1. We don't add these powers, you just take the largest power, so my degree is 11 for this term. Okay, so that's how you find degrees. And we do use it later on, what we need to find degrees for. So these 2 terms, I got a 3 and a 5, so the degree of this term is 8. Here I just have an x to the 4th, so my degree is 4, so the degree of the whole thing is 8. The next one, I got x to the 5th, y to the 1st, so if you add those 2 together, my degree for that term is not 5, sorry, that's 6. 4 and 3, so my degree is 7. 1 and 1, x to the 1st, y to the 1st, that's the degree of 2. So you take the higher degree of all of them. So the degree of the whole polynomial is 7. Okay, so that's how we find degrees. Addition, subtraction, and multiplication with polynomials. Okay, so with addition, basically you have 2 sets of parentheses and you're adding them. You just basically combine like terms. And we'll do a problem like that in a minute. For subtraction, there's a minus sign in between them. You got to run that negative through the quantity, change the sign of these 2 terms inside the parentheses, and then combine like terms. So run the negative and combine like terms. Okay. Multiplication. Usually you're dealing with distributive property here. We'll do a couple problems like that. Or FOIL, a lot of people call it FOIL, or box method. I'll kind of show you a little bit of both. Okay, so anyway, the big thing here, number 3, example 3, is we're subtracting this polynomial, the x squared plus 4x minus 2. So everyone usually makes this x squared negative because you're subtracting it, but we don't change the sign of these 2, and that's kind of a problem. It's a mistake. There's a couple ways to look at that. You could just run the negative through here, okay, and get 3x squared minus 2x plus 3. And then that's minus an x squared. And then it's minus positive 4x, that would be negative 4x. And then minus this negative 2 would change that to a positive 2. One way I like to look at it when you run that negative through is there's like a little negative 1 here, and you're basically distributing that negative 1 through the quantity. So negative 1 times x squared, that's negative x squared, or minus x squared. Then the negative 1 times the 4x, that's negative 4x. And the negative 1 times the negative 2, that's positive 2. That's kind of how I would do that one, I guess. And then it's just a matter of combining like terms. Well, I got a 3x squared and a negative x squared. Well, that's 3 plus a negative 1, that's 2x squared. I don't make it 2x to the fourth. You don't add the exponents when you're combining like terms. You just leave that as an x squared. The only time you change the exponents is if you multiply two variables, okay? So anyway, then, so these are taken care of. And then I got negative 2x and negative 4x. Well, they're both negative. That's a negative 6x. And then you got your constant, 3 and 2, that's 5. What's the degree of this term? Well, the degree of the first term is 2, the degree of the second term is 1, the degree of 5 is just 0. So that would have a degree of 2 overall, just kind of looking at that. The main thing with degree is when you're looking at these polynomials, the degree tells you how many zeros there are or how many factors you would need to multiply to get that polynomial. Addition. Well, if it's addition, you can go ahead and drop parentheses right away and just combine like terms. You don't have to rewrite it. I'm just showing you that basically it's plus a negative 3x squared, plus x and minus 3. I'm just getting rid of the parentheses and then combining like terms when it is addition. Some people like to multiply these because they think it's multiplication. Whenever you see parentheses, a lot of times you think it's multiplication, but in this case, there is an addition sign in between there, so you're just combining like terms. Okay, so 5x squared and negative 2x squared, they're like terms. That's going to give me 2x squared. Negative 4x and x, that's negative 4 plus a 1. That's negative 3x. 1 and negative 3, that's going to give me negative 2. So combining like terms. We got some more subtraction here. So I guess, like I said, run that negative through there. If that doesn't make sense, just multiply through by a negative 1. So the first polynomial, you don't do anything to. That's just, you're not subtracting that, so it stays negative x squared plus minus 3x plus the 4 here. I'm subtracting this polynomial, so negative 1 times x, that's negative x squared. Okay. And then negative 1 times 2x, that's negative 2x. And negative 1 times 5, that would be negative 5. That's how you subtract. And then just combine like terms. Negative x squared, well, that's like a negative 1 and another negative 1. That's negative 2x squared. Negative 3x, negative 2x is negative 5x. And then 4 and negative 5 is negative 1. There's my answer for simplifying that expression. And then we got another addition here. When people see this, two terms and two terms, they think multiplication, but it is addition. So we get into the mood of addition, but this is a 3x squared and this is a negative x. They're not like terms. They don't have the same exponent. So it's just 3x squared minus x. That takes care of these two. And then the negative 6 and the 1 are like terms. They're both constants, so that's negative 5. Okay, now some multiplication. So this is just negative or positive 2x times this whole polynomial. You're just using the distributive property. So the first part here, 2x times 7x squared, right? You multiply the 2 and the 7, that's 14. Now the x to the first times x squared right here, multiplying these two, you add those exponents. That becomes x cubed. So x times x squared, add exponents, that's x cubed. Okay, so basically we're multiplying by 2x. That's x to the first. I'm just going to increase these by 1 every time. Okay, there's no x on the last one, so you really don't do that. But anyway, so my first term here is 14x cubed. Okay, I kind of showed you why. And then 2x times negative 3x. 2 times negative 3 is negative 6. And then the x times the x to the first, I can add the 1 plus 1, that's x squared. And then 2x times 5, that's just plus 10, and then carry along that x. Don't have an x here, so that's not going to increase by any. Multiplying by negative 2a. Okay. Distributive property. Negative 2 times negative 3 is 6. A to the first, a squared, that becomes a cubed. Negative 2 times negative 11, that's positive 22. And the a to the first times the a to the first, add those exponents, that becomes a squared. Negative 2 times 20, that's negative 40. And then we just carry along the a. And that's it. So multiplying. Okay, this is a trinomial, 3 terms, times a binomial, 2 terms. Basically, I have to take every term in here and multiply it by every term in the binomial. You would basically use distributive property, what do I want to call it, 3 times. You could do box method. I'll show you box method on the next one. For this one, I'm going to use distributive property, but I'm just going to multiply all 3 of these terms by n first. N times n squared is n cubed. N times 6n, that's plus 6. N times n is n squared. And n times negative 2 is just negative 2n. Then, to make sure you multiply every term in the trinomial by every term in the binomial, now I got to multiply 4 times all these terms. So 4 times n squared is plus 4n squared. 4 times 6n, that's plus 24n. And 4 times negative 2 is negative 8. Okay, now just combine like terms, clean it all up. There is only one n cubed term, so I'm not going to combine that to anything but the 6n squared and the 4n squared. 6 and 4 is 10, that's 10n squared. Not n to the 4th, just n squared, because now I'm adding again. Negative 2n, 24n, negative 2 and 24 is positive 22n. And they're done. All I'm left with this is constant, that's negative 8. What's the degree of this polynomial? Well, there's a 3, there's a 2, there's a 1, and 0. 8 has no degree. So the degree would be 3, okay? Just so we kind of know that. Anyway, that's our answer. Okay, some of you like the box method, and that's fine. This is 3 terms times 2 terms, so my box is going to kind of be 3 by 2. So I guess I can put the 2x squared here, the negative 4x, and the 5, and the 3x here, and then that's a minus 1 here, so just a minus 1. And now, here I'm going to multiply the 3x and the 2x squared. That's going to be 6x cubed. Now I'm going to multiply 3x times negative 4x to get this term right here. 4 times negative 3 is negative 12. X times x is x squared. And finally, 3x times 5 is 15x. Negative 1, now to get this bottom row, I'm going to multiply all these by negative 1. 2x squared times negative 1 is negative 2x squared. Negative 1 times the negative 4x is positive 4x. And finally, negative 1 times the 5 is going to give me this square in here, and that's going to be negative 5. Okay, so that's the box method. You could do distributive property twice, multiply 3x by all of these, and you get all these top terms. And then negative 1 times all of them, and you get these bottom terms. And then combine like terms. That's what we got to do here. There's only one x cubed term, so that's 6x cubed. If you look at here, there's 2x squared terms. They're both negative, so it looks like negative 2 and negative 12 is negative 14x squared. 4x and 15x, that adds up to 19x. I don't make it x squared because I'm just adding, not multiplying here. And then finally, a negative 5. And this would be a degree of 3 also. Okay. Suppose R and W represent 2 genes that a plant can inherit from its parents. The terms of the expansion of r plus w squared represents the possible pairings of the genes in the offspring. So write r plus w squared as a polynomial. So they want us to multiply this out. R plus w squared. Now, here's what not to do. A lot of people would say, oh, I square the r and I square the w, and don't write this down because it's wrong. Get r squared plus w squared. That is not how we do that. I'm multiplying two terms here, so I got to take r plus w and multiply it by r plus w. Multiply it by itself. We're squaring it, I guess. Once again, if you want to do box method, r plus w and r plus w like that. I'm just going to use distributive property twice here, or some people call it FOIL. R times r, right there is r squared, and then r times w is plus rw. Okay, then I go to this w. After I'm done with the r, I multiply w by both terms. W times r is, I'll put rw, put the alphabetical order, r would come first, so that's why it's rw, not wr. And then w times w is w squared. These two terms are like terms. So this is r squared plus, this is 1rw plus another 1rw, that's 2rw. So that's taken care of, and then plus w squared at the end. And that would be my answer. Okay. The volume of a rectangular prism is given by the product of its length, width, and height. Volume equals length times width times height. I don't know if I can draw a picture of this. That's kind of good, I guess. Anyway, length, width, and height. You're going to multiply those three in order to get your volume. Well, the length is b squared, so I'm going to take b squared times the width, which is a units, times the height, which is ab plus c. Okay, I can't multiply all three of these at once, just like 2 times 3 times, we'll say 7. You'd multiply 2 and 3 first, that's 6, times 7, that would be 42. We're going to kind of do the same thing here. I'm going to multiply these two first. B squared times a, that's just ab squared, times ab plus c. Well, the second multiplying, I'm going to have to use the distributive property. Okay, so I'm going to distribute that. ab squared times ab, well, a to the first times a to the first is a squared. B squared times b to the first, add those exponents, I get b cubed. So that's ab squared times ab. Now distribute it to the c. ab squared times c, well, none of the variables are alike, like we had here, two ab's and an ab. So it's just ab squared times c, or ab squared c. That's it. And now you can go ahead and work on your 7-2 worksheet. And that's it. We'll see you tomorrow.